Okay, we are in 1.4 graph of a function. So in mathematics, a function can be described in several ways. I'm going to say 4 ways. There are other ways we won't consider here, but mainly it's 4 ways. Okay, so the first way is using word that we is called like verbally. Second way is using table. Okay. Using word. Using tables. The third way is using graph, or we call it graphically. And the last one is using an equation formula. So let's practice with these 4 ways to describe the functions y equal to x squared. Okay, so let's move down here. So for y equal to x squared verbally, what I can say in word is, let me type it. The output is the square of the input. Okay. And for graphically, as you know, no, actually, let we go ahead and work on the tabular or using using table first. So for x is going to be in the left of the table, left column of the table, and for fx is going to be the right column of the table. We're going to be equal to x squared, right? Okay, so let's say if I have if I say x equals 0, then f of x must also equal 0. If I have 1, then 1 square also going to be 1. 2 square going to be 4. 3 square going to be 9. So, or maybe actually I should also using some negative number. I'm going to use -2. It's going to give me 4 also. Okay, so I will go ahead and show you the graphical way, which is I'm gonna using some point that I just found from the tables there. So 2 and 4, so here, right? And then same way with the left one, you can have 2 and then -2. This is the other one. -2 and 4. All right, so then we can grab it. Not perfect, but you know. Uh-oh. Okay, something like that. Okay. So that is a graphically of the x equals to x squared. Mentally, I mean, as the business people, you may gonna use decimal to show your boss, but I would say you may have to sign up first by follow the step in here to sign up for an account. You may use just Google account or email address here to sign up for the Desmos, and after that you will have like an account with Desmos and work on it. So I myself have have my own one. So let me get into and show you. So let's say I forgot mine. So let's see. Anyway, that's okay for now, but when I need it, I will get into the account, because when I have account, I can save it easily. So let's say if I want to show the graph of y equal to x squared, right? So as you can know that the x squared, you need to use the button with the hat and then move it up. So to get the y equal to x squared, right? So in here, you need to zoom out a little bit to see the whole graph, right? So this is the graph of y equal x squared. Okay. And lastly, the fourth one is the equations. So it's going to be y equal to x squared. And in this section, we will mainly talk about the graphical methods. All right. So in this section, we're gonna focus on this way. Okay. So now let we start with example 1.14 here. Temperature varies with the time of day. There is no equation for temperature functions. T(x) here. Only a graph showing the temperature reading at several times during the particular days in a certain cities. So let's investigate this graph and how to interpret it. So if I want to know what does x equals 10 mean, so you have to look at the you have to look at the axis here. What does that stand for? And you see that is stand for the hour past midnight, right? So that means you will say x equal to 10 mean that it is 10 hours past midnight, right? It is 10 hours past midnight. Or in another word, I say 10 a.m. Right, 10 a.m. Okay, and similarly, what does a x equal 13 mean? It is 13 hours past midnight, or I would say 1 p.m. Okay. So how do we interpret the dot on the graph? So as you see over here, I have this dot. What the coordinate of this dot? So you see the x value was 14, right? So 14. And the y value is 72. So I write out 14, 72 for this point. And what does that mean? 14, 72. So we give us we tell us at x equal to 14 or 2 p.m. at 2 p.m. What is y intercept y axis stand for the temperature, right? The temperature is 72. 49. All right. And Hasi say, what does the T20 mean? You have to, it mean like, add, add T, as X equal to 20, which mean what? X equal to 20. This inputs X equal to 20, which give us at 8 p.m. All right. So at 8 p.m. or the 20 here. Okay. You will have the values of T20 will be equal to 64. So you will say what? At 8 p.m. the temperature equal to 64 Fahrenheit. Oh, actually, if the question just say T of 20 mean the temperature at 8 p.m. So I should just say that better. Temperature at 8 a.m. Right? We don't. I mean, if you are given T of 20 equal to 64, then you can say that. But in here, just say what is T20 mean? So it means temperature at 8 p.m. Okay. So the question say what is temperature at 10 a.m. Then you will just look at the 10 a.m. here, right? You will see that at 10 a.m. You will have 60 at the temperature, 60 Fahrenheit. So I will say 60 Fahrenheit. What about 6 p.m.? Then you have to think about what is 6 p.m. 6 p.m. is like 18 hour past midnight, right? So gonna be X equal to 18. And you look as when it was 18 and map to the graph, you will have this point which is 18 comma I would say between 68 and 72 gonna be 70. All right, then I want to say about 70 Fahrenheit. Okay. So during what period did the temperature increase? So if you look at the graph, right, when it's increasing, and you see that maybe you the green one here. From here to here, it's increase. Here to here, it's increase. Here to here, increase, and to here. All right. So that means from let's say from the X values here from 4 to 16 hour after past midnight. I mean, our past midnight will be will will make the temperature increase. So so I would say between 4 a.m. to 16, so we mean 4 p.m. Right, the temperatures increase. Okay. Okay, so that's gonna be for this examples, and for the next one, suppose we have demand function for selling ball or pens is F of P equal to 160,000 minus 200,000 P, where FP is number of pen, which is a demand, and that can be sold at the price of P dollars, and the revenue is the price per item sold time the number of items sold. Okay, so in most cases, the number of souls is a demand. Okay. So we have revenues, as you see, is a price per item sold time. Let me highlight this. Revenues is the price per item sold, and then time, the number of items sold. Right? So price per item sold and the number of items sold. Keep in mind that number of items sold is a demand, which is F of P, right? And price per item sold is just P. So that's the reason why I have P times F of P to get the revenues function with respect to P. So then I'm gonna just substitute P and F of P. F of P was given as 160,000 minus 200,000 P. And I substitute those two numbers, the groups into it. And then I distribute to get negative 200,000 P squared, since I distribute, right? Here, all right? And then plus with 160,000 P. So what does a revenue 0.30 mean? So I have 0.30 here. I'm gonna move to that spot. What does that mean, right? I'm gonna say and price, revenue and price is 0.30. Yeah. And we don't need to specifically know what is that. I know that it's supposed to be like 30,000, but we don't really need to know that, right? Input B say find the value of R of the value at 0.30 here and interpret the result. So by graphically, and you see there, right? You see it's gonna be like 0.30 comma 30,000. I would say that, right? So you might think like that, right? But is there any other way? I mean, since this is just by eye, it could be, not really sure. How can you have that, right? You may have to check with the decimals. So let's go ahead and get into the decimal and I'll show you. Okay. So first you need to type of I think P doesn't work in decimal. Let's check that. Equal to negative 200,000 P square and then plus 160,000 P. All right, so look like we need to adjust something. First, click on the graph setting here. You need to adjust the x-axis. You don't need the negative value. So maybe just move up to -1. And then the value for the x-axis, which is the value of price, you, according to the graph here, you see that the price going to be 0.80. So you're going to adjust to 0.80 only. All right, nice. And then for the y-axis, you may have to start from -1 or so. All right. 91, and this will be 81. All right. And then what this could be 0.1. That's good enough. And y gonna be in between -1 to up to what? Up to 40,000. That's right. Okay, perfect. All right, so and you see right now, this is the graph that you want to show the boss. Say you want to find revenues as 0.30, right? So if you move around, right, you can see that this part here. Another way is just using R of the 0.30 here, right way. That's going to show you 30,000. Okay. If you want to show the put to the boss, you're gonna label that point, say 0.30 comma 30,000. Right, that is the point you need. Right. So so now let's come back with the column B here. You can see that it's supposed to be R of 0.30, which equal to 30,000. Okay, and interpret to say totals revenues at price is $0.30 is $30,000. Yeah. look like total revenue. Okay, total revenue, maybe right like this, is from selling selling ballpark pens, from pens as the price. Is 0.30 H. Okay, that makes sense. Okay, so how many pen can be sold if the price is 0.30 per pen? This means we're looking for the demand, right? Demand is F of P. And in this case, we have P equal to 0.30. So we mean F of 0.30. And you will have to substitute into the function there, right? So we equal to 160,000 minus 200,000 times with P with 0.30. I gotta move this down here. Okay. What is that equal to? You can go ahead and calculate that. Okay. And this is going to be 100,000. Nice. So that means what? If the price is $0.30 per pen, then the demand will be about like 100,000 pens, right? Okay. So what does it mean that the revenue function is decreasing when the price is greater than $0.40? So look at the price as 0.40 here. It was a maximum of revenues. And after that, it's just decreasing. Even though if you think like, if you want to have if you increase the price, right, the revenue is supposed to be higher. Well, not really. It actually depends on two things: the demand and the price. If you increase the price, the demand could be lower, since do you want to buy a pen with very high price? No, right? So I would say as price increase, demand decrease. And so then therefore revenue could be decreasing when the price is too high. Yeah. All right, so now I will show you by using decimals um, and draw the point forward pins and answer these problem, right? So let me see. Okay, so this is exercise 1.14 and using decimals tutorial that I have made. Let me open it first. So let me get into that. For this exercise, I don't think that we have the function of it, so we don't want to using decimals on this one. And I would say we don't really need it since we did have the graph here. Okay, so now for this problem, we can have domain. All right, what is that from the horizontal, right? It's going to be the horizontal. Right, and what's the range gonna be? How vertical it's go, right? So it's go up to this point over here. So I wanna okay. Yeah, I would say up to here. Good enough. All right. And what is the revenue from selling 40,000 pen? What is the revenue of 80,000? So all of this is from the graph. So I would like to let you guys to practice on it. But each for what number of pens, so will the revenue be above 14,000? So for part E, you have to watch out a little bit. It say like in order to get the revenues above 14,000. So where the 14,000 is over here. Okay. So you will need the revenues more than that. So we mean what? You want to sell in between these values up to this value to get the revenue to be more than 14,000, right? So it is 14,000. All right. So go ahead and look at the graph, discuss which one next to use, and work on this one, right? And if you are working at home, you may have to take a look at the other one, or maybe discuss with the other classmate from the group me to get answer this one. Okay. So we're gonna move down. And now, as I stated before, in this section, we mainly talking about how to graph a function. Okay, and now the as you know that the graph of a function is a visual way to show the relationship between two numerical quantities. So let's we look at what makes a good graph versus one that leaves us asking too many questions. So let's go ahead and work on the examples 116, the supply and demand equation for selling an inexpensive brand of wristwatch is this one, this function here. And where F of P will be the demand for watch at a price of P dollar. Now, look at the first one. Do you think this one can be acceptable if you show the boss, right? So I mean, absolutely no, right? Because would you understand what is this? No, right? So what is wrong with this? With this graph? All right. So first, it doesn't have tick marks, right? No tick mark. What else? It doesn't have axis labels, so no axis table label. And I would say inappropriate range, right? In a range. We need to zoom in. Since you can see that, do we need to care about the values outside of this, right? So what else? No caption, so all right. This is number 4. What is this talking about? So clearly this is unacceptable. This is unacceptable. Right. Yeah. Now, let's take a look at the second one. You write rabbit. Okay, so let me. Oh. So how to make this become a better one, right? So I would make this in decimals. Okay. So this one. So the functions is f of p equal to 5,000. Yeah, sure. Minus 125p. Okay. So as you see right now, I having like a line. It should look like, you know, it's not easy to see. Is that so? We need to change the scale a little bit, right? First, click on this one. I would say, let's see. I groups you the x-axis must change. Let's say change to change to be up to 50. And the y-axis going to change from 91 and up to 5,001. Let's say others. Yeah. So this look better. Yeah, as you see right now. But I mean, you have tick marks, right? Yeah. You have what do you have? Did you label it? You have it, right? So you may have to label it. So what do you label for the axis? You will say price in dollar. What you label for the y-axis? Say F up P. So here's P, which is demand. Okay. Last thing is like a capture, and I'm not sure if this one has a capture for us. I don't think so. Let me see. Right. So for the, I mean, in the dashboard, it doesn't give us a chance to write the titles, but basically, you can, copy this and copy this picture and then put it into the into just the files and show the boss, right? So so what I can do in here, and you see that I did adjust it up to like 50, right? So let's say 10, 20, 30, 40, 50. That's too small. Let me, you know what? And I'm like, it's 50 here. 50 here. Then middle with 25. So then 10 here. Maybe I'll make it better. See, do it one more time. So let's make it bigger. 10, 20, 30, 40, and 50. Okay, now it's perfect. So here's 10, here's 20, here's 30, here's 40, here's 50, and I'm gonna say here's price. P in dollar, right? And then for the vertical axis, I'm gonna say F of P, which is demand. Okay, so I can also say up to 5,000 here, but I start from 1,000, 2,000, 3, 4, and 5. 5,000 here. Yeah. And then I say 4,000 here, 3,000 here, 2,000 here, 1,000 here. Right? And then, I know that the functions, in order to grab the function, I need the slope and y-intercept, right? So since I have f of p equal to 5,000 minus 125 p, I need needs to find the p-intercept. So you're gonna set f of p equals 0. So we have 5,000 minus 125 p equals 0. That's, you can have like negative 125 p equal to negative 5,000. And so then that means you have p will be equal to what? P will be equal to 5,000 divided by 125. So negative both sides here. We give us p will be 40. So that means what? P p-intercept is 40, right? So you will have a p-intercept at 40. What about if I want to find f of p-intercept, right? You're gonna set p equals 0. You will have 50,000 minus 125. So this is f. So f of 0 will be 5,000 minus 125 times 0. So that's give us f of 0 equal to 5,000. So fp intercept is fixed fixed demand gonna be equal to 5,000. So then you will have the fp intercept is at 5,000 there, and then you will have to draw a line come from 5,000 there and to the 40 there. All right, so let me try to draw it. Not an easy one, but let's try. Please work. All right, so that is acceptable by hand, okay? But if you as a accountant, you may show the boss by using decimals. We can tell us where is the where is the y-intercept or the in his fp-intercept, and the p-intercept is 40 over here. Okay, so So we also need to state this is the price demand relationship for what? All right, so now that's gonna be for this graph. So I would like to show you a particular linear function that we care about is the cost functions. So cost function. And this typo here. This supposed to be typo. Say cost function. And the cost production as a function of the number of items produced, there is a fixed cost and per item cost. So I will have to highlight two things. There's fixed cost and another one is called per item cost. Yeah. So the cost function has a form as per item cost multiplied by x and adding with the fixed cost. Okay. So for example, fixed cost, usually you can think as something like renting, like a internet that you always have to pay fixed. For per item costs, it could be something such as like raw materials, labor, right? Because the more item you make, the more cost you will have to pay for it. So that's called per item cost. Okay. So now, I would like to show you how to graph the cost to grow the rose bush by using Desmos. So let's we start with using the function cost over here, C of x equal to 1000 plus 10x here. But before going to Desmos, let's take some fixed cost and per item cost first. So you know that per item cost is a cost that's multiplied by x. So that's in here. And as you notice there, per item cost usually is a small amount, right? And the fixed cost is usually a huge amount. Okay. So in this case, you have fixed cost is $1,000. Okay. And for the per item cost, it's gonna be $10. All right. Keep in mind that the fixed cost and the per item cost supposed to be in the same like unit of time, such as like if we count fixed cost in by monthly, then you may have to think about per item cost also using by monthly. Okay, but we not go deeply in that yet. Okay, so now let's we go ahead and using Desmos to work on this column. Okay, so I also have a Desmos tool for this column. So let me open that. Let's see. should be this one. I think this one, okay. Yeah. So first we have to go to the dashboard and click the math tool. Okay, so I'm gonna open the dashboard first. Okay, so you will see the math tool here. Click on graphing calculator, that's right. What else? You wanna input 1000 plus 10x into the first net box. So input this, okay. And right now, after you input, you don't see anything yet. So what happened? You need to adjust the range, okay, the zoom in, zoom out there. And then you also need to input the revenue, but at this point, later we do that. So I will click on the button here. Okay. Settings, right? And then change the x-axis to be let's say from 0 to 120, that's right. 0 to 120. Okay, so let's see let's see the cost. Haven't seen anything yet. Okay. I need to adjust the y-axis also. The y-axis is gonna start from 0 to 13,000. So 0 to 13,000. All right, so now I can see the graph, right? Okay, so the graph starting from 1,000, which is a fixed cost. This is a function, the function fixed of the cost, right? So let's label something. Labels x is gonna be the items, x number of items. Okay, and the y value is gonna be the amount of money, so dollar. So okay, so this is the graph of the cost. Okay, so let's we go back to here. Okay, so what makes sense for the domain and range for CFX? As you see that domain for is interval of x in here, you can start with x equal to 0 as the smallest. Okay. What about the maximum value for the x? So you may have to think about, can x equal to a positive infinity? is the largest? Well, actually, in the real life, as the companies for Rose Bush, you may have to think about restricts this, and let's suppose we limit ourselves to a geographical areas, for example, like Hayward, right? And instead of the whole Bay Area, yeah. So that means I can say X gonna be equal to 12,000. X maximum can be is 12,000. So then domain, I can say domain now is X in between 0 and 12,000. Or in the interval notation, you can write as 0, 12,000. For the range, is an interval for C of X. And you see that if you start from the X equal to 0, or maybe I'm gonna type this. We have C of 0 which equal to 1,000 plus 10 times 0. Use either color. So we give us 1,000. Right? This is a minimum cost or fixed cost. Right? And maximum for the for the limit of demand is 12,000. I will have the cost at 12,000 will be 1,000 plus 10 times 12,000. And you can calculate that to get it's gonna be 13,000. This should be 1,200. I said this should be 1,200 only. Yeah. Right. And that's what. No, this one. Yeah. 200. Yeah. So. Yeah. All right. So then the maximum cost can be is 13,000. So then the range I can say is R and makes in between 1,000 and up to 13,000. All right. So so this is a range of this function, and the revenues are X from selling X rose bush. Now we can start drawing the revenues function on the decimals. So let's start now. X equal to X times 45 minus 0.05x. Yeah. So yeah, so I did input this step, right? Okay. So now, yeah, now you're in here, this, right? So now the graph have two things. One is the function of cost, and another one is function of revenues. Okay. Basically, if you shows this graph to the boss, if I was a boss, I would say it's okay to me, right? However, if you really think about, do you need the areas over here, like after this guy? Do you need this one? Do you need this one? No, right? You don't really need this one. The reason was after X values equal to say 900, right? If you get like 900 value here, 900 demand equal to 900, you will have zero revenues. Right? I mean, with the price, right? That's price of demand. Demand is 900 because when demand is 900 here, the price could be you know, the gap the demand is 900, the price could be very low, so that might revenue to be zero. Okay, so so at that point we don't need to go further than 900. Do you agree with me? Right, since after that all revenue is going to be negative, right? We don't want revenue to be negative, okay, because that's when we lost, and you don't want that to happen. So you want to focus on the area that's like before 900 and after 0. Yeah. Okay, so because of that, then I have to adjust something, right? So I will have to adjust X to be up to 900 now. Okay, and maybe the y-axis also need to change. In do I need to have to consider about the values like up farther than 1,000 here? Not really, right? You can just go up to 10,200. Okay, because the maximum revenue is going to be up to it 10,025. Yeah. So yeah, I can adjust this to make it small. So 10,500. Right? So now you will see you make like this very clear graph for the boss to see it. Okay, so now let me go back to here and so answer the question here, right? So what value of X ensure that the revenues of X is not negative? So according to the graph, right? And you see that that's according to the graph. We can see that X need to be in between 0 and 900 to have revenues not negative. Okay. So if you want to make sure by hand, you can solve for this, but Desmos actually can help us that. So I will not, it's not necessary for us to work on it. Okay. So I just need you to know where it's supposed to go, right? Just from 0 to 9 for the X only to make the scale to be the best. All right. And what else? Yeah. And you may have to draw the graph of the cost together, right? So and you see the cost was that from 0,000 here. So 0,000 here. 1 point and another point when it's 900 is up to 10,000. So 10,000 over here, and then you're just gonna draw a line go through these 2 points, and that will make the line at the cost. Okay, it is COX, and it's a revenues function. Okay, so so at this point, I just gonna need to adjust only the adjust the X value from 0 to 9 instead of using the domain as before was from 0 to 1200, right? And the range I could adjust or stay there as up to 12,000. That's fine too. All right. So this is a this is done. This one. Okay. So let's we go ahead and working on the example 1.18 selling microwaves. This is the price demand equation for selling microwave. That function is fp equal to 300 minus fp, I mean minus 2p equal to 300. And whereas fp is demand in thousand. Okay, so I mean let me use notation. Yes, in thousand. Okay, and this is the demand. Oh, yeah, and p is the prime. So yeah, so we need to label the tick map on both axes, right? So basically we want to find h question mark here. So we know that we know that this gonna be the p-intercept, and this gonna be the f of p-intercept. So I would say we're gonna find those two first, right? So find p-intercept first. How to do that? Set f of p equal to 0. Okay, so come back with the function. I have 0 equal to I make a typo here also. Okay, so let me see. It's supposed to be f of p plus 2p. Okay, so let me clean this up. Yeah, typo. Let me call this, please. F of p plus 2p equal to 300. Okay. So there. So there. It's gonna be what? 0 plus 2p equal to 300. Then I have p equal to 300 divided by 2, which equal to 150. So then the p-intercept here is going to be 150. Okay, so let's find the fp-intercept. So in order to find fp-intercept, you're gonna set p equals 0. Then you have f of p plus 2 times 0 equal to 300. And then you have f of p equal to 300. So it is 300. Well, I can say it's 300 here. Here's 150. Okay. So so since we have 6 tick mark, right? 1, 2, 3, 4, 5, 6. So then, what I gotta do? So in p-axis, we have 6 tick mark. So each tick. So then we're gonna using 150 divided by 6 to get, like, let's label here as A, B, C, D, E, and this F. See that, right? So we have A. Let me say A will be equal to 150 over 6 will equal to 25. Yeah. And then, so then we're gonna have B gonna be just 2 times 25, 2A, right? 2 times A is 2 times 25. B equal to 50, right? 50. We can keep going with adding 25 to get the next. So, all right. And so on. So in F of P axis, we have 3 tick marks. Oh. From origin to FP intercept. So we have, let's say, M here, N here, O here. All right. So M will be equal to 300 divided by 3. That's equal to 100. And N will be just, keep going with 100. 200. And O will be 400. Right. I can fill the rest. C equal to 75. P equal to 100. E equal to 125. And F going to equal to 175. So that's going to be it for this problems. Okay. There is problem similar with it in the homework. So make sure to practice with it. Yeah. So and this problem below here is exactly the same as from above. So let's work together on it and submit the work as a group work. Okay, so I have finished section 1.4, right? So we'll see you in 1.5 later. All right. Have a good day.